Okay, so today, what I want to do today, I want to go back. We've talked about order of operations a little bit. Today, I want to go back to that, but we're going to kind of turn things around. We're going to focus on just, you guys have all seen this, I'm sure, but we want to talk about how we can use PEMDAS to solve linear equations, right? So how do we do this? When we're solving a linear equation, which is, those are simple equations, right? Linear equations are equations where we've only got one kind of variable. You actually could have more than one kind of variable, but we'll get there later. For now, one kind of variable, and it's always to the first power. It's never being multiplied by another variable. It's never on the bottom of a fraction. It's always just by itself in a term, and it's to the first power. So, simple equations. How do we use PEMDAS to solve? Well, there's two steps, two parts to this. First is we've got to simplify as far as we need to until we can point to a single variable. So like let's say x is our variable. We need to use regular PEMDAS top to bottom until we can point to a single variable in the equation. And as soon as we can, as soon as you can point to a single x or whatever your variable is, then you're going to flip around PEMDAS and you're going to use inverse operations and you're going to go from bottom up. Those are the order in which the steps need to be used to isolate the variable. Solving a linear equation is exactly the same thing as isolating the variable, and that's a good way to think about it. So let's start really simple, and let's just go through some, this process with some very, very simple examples. So here's one, right? Linear equation, only got x's. Notice the x's are to the first power, okay? So ask yourself, first thing you do when you're solving a linear equation, can I point to a single variable? Vote with your thumbs. Thumbs up for yes, thumbs down for no. Can you point to a single variable here? Okay, I'm seeing some thumbs up. That's right. The answer is thumbs up. How come? Because there's a single variable right there. My variable in this case is an x, and I can point to, there's only one x in the equation that I can point to, right? So when we ask the question, can you point to a single variable? That's what we mean. There it is. Yes, we can. And if the answer is yes, then that means we're going to move into inverse operation mode. We're going to use reverse PEMDAS, bottoms up. Start at the add and subtract and work our way up. So let me ask you here then, to isolate that x, what are the things I need to do? Step number one, do I need to add or subtract anything to both sides? What do I need to add to both sides, everybody? I need to add positive 3, right? I need to undo. What's being done right now? I've got an x on the left side and a 3 is being subtracted, right? I have to undo that by adding 3. Okay, give me thumbs on this. This is making sense, these inverse operations. Okay, I knew it would, but we're still kind of reviewing a little bit, right? So first step is add 3 to both sides. So there's step one is add. What's that give us? If we add 3 to both sides, then the 3's cancel. And we get 2x equals 15. Okay, this brings up something really important. When you're doing inverse operations, so you're going reverse PEMDAS, every step you make, you should accomplish something. You should feel a sense of accomplishment because you always get to cross something out. It always takes you one step closer to getting that x by itself. And look, it did. We started off with the x on the left side, and there was quite a bit of stuff. Well, we were multiplying and subtracting. So the x was not by itself. We added 3 to both sides, and we crossed out that negative 3, and look, we got closer. The x is a little bit closer to being by itself, so now we move on. We move up the ladder to the next row, multiply and divide. Is there anything I need to multiply both sides by or divide both sides by to get the x by itself? What do? Divide by 2, of course, right? So divide by 2, there's step 2, is going to be division. And again, look what happened. We got to cross something out. Okay, so it took us one step closer, and now we're done. We have the answer x equals 15 halves, and that fraction can't be reduced so we're done, okay? If you're not crossing something out when you're isolating a variable, you're doing something that's not correct, right? Sometimes there are other steps you could take to solve an equation that wouldn't involve crossing something out, but they're not as good. If you can point to a single variable, every step should mean you're crossing something out. So if you're not, go back and repeat that and ask yourself, okay, what could I have done to cross something out there? Okay. So we got an answer. Now, when you're doing your homework, I don't think it's really important to always check every answer. That takes time, and you have a limited amount of time in your day to practice this stuff. And so I intentionally built the homework in this online environment so you can easily just check your answers and get feedback, and if it's wrong, there's no penalty. Just load up another one and do it again. That's fine. But on a test, should you check your answer? Absolutely. Why would you not? That would be a really kind of a dumb move not to check your answer. On a test, at this level, I really try not to impose time restrictions on tests. You'll see when we get to one, I'll set it up so if you don't finish, you can come back and finish it later. It's set up so that's, it's secure. I'm comfortable doing that. And you'll see why when we get there. The test can be taken in multiple sessions. So always take a little extra time if necessary and check your answer. Anytime you're solving an equation in math, that means you're going to get solutions that you could go back and check and know before you hit submit on that question on the test if it's right or wrong. How do you check to see if you're right? How do you check a solution? Yeah, you plug the answer back into the original equation, right? If this is correct, this is how we say it in math, it will satisfy the equation, which just means it's going to make it true, right? So we're just going to plug it back into the original equation wherever we had an x. Okay, so you can do that, but it's a fraction, right? That's kind of, it's just a little bit tedious sometimes to plug answers back into the original equation and check. I'm going to show you a great shortcut here. I mean, I think maybe we talked a little bit about this before Roundup, but we definitely want to hit it again, this idea. How can you use Desmos, either scientific or graphing? There's two different calculators, Desmos Scientific and Desmos Graphing. You need to know how to use them both real well, and you will. You use them all the time in here. On tests, you'll either have access to Desmos Scientific, like on every test you'll have access to that, and sometimes on certain tests I'll give you access to Desmos Graphing. Not always, but you'll always have Desmos Scientific. So how could you check? I'm going to show you a great trick. Here's what you do. So you go into Desmos Scientific, and we're going to, our job here is to plug our answer into the equation and see if the left side is equal to the right side. If both sides are equal, then it worked. We checked our solution and it was correct. So the best way to do this is always to use function notation. We're going to let f of x define the left side. So f of x will always equal whatever's on the left side of the equation, and g of x will equal what's on the right side, if there's an x on the right side. If there's not, if it's just a number, then we don't have to worry about it. But if we had x's on both sides to start with, then we would use f of x and g of x, and we'll see an example like that today. So first thing we would do is use this function notation. We'd say f of x equals, and then whatever the equation is on the left side, we just type that in. Okay, so there's our function. Just hit enter. It's in there. How could I plug our answer, 15 halves, into the left side then? See if you remember this from previous years. How could I figure out what I get on the left side when I plug that in using function notation? What's my way with function notation of plugging a number in for x? Remember? That's it, right? We're just going to trade the x for the number that we're plugging in. That's it. So if we want to plug in 5 halves or 15 halves, we would just do f of, and in the parentheses, instead of x, we're going to substitute the number, 15 halves, and look what it does. What's it tell me? Whoops, what's the output there? Look at that, I plugged that in, and over on the right side it said it equals 12. So it's telling me that when I plug 15 halves into the left side of the equation, I get 12. Well, that works, doesn't it? Because the right side is 12. I'll take a picture for our notes here. Okay, so that worked, right? We got 12. So it checks out. We know that we're getting that right on the test no matter what. We plugged it in and it worked. Before you even hit submit, you know you got it correct. There's no guesswork. Okay, give me 1 to 5 on that process. Does that make sense? Okay, the video will go up today, the notes will go up today. If you need to go back and see that again, just click on the YouTube video and just watch that little trick again if you need to when you're doing the homework. Again, normally on homeworks, you don't really need to check stuff, but try it a couple times just so you get used to the trick so you know how to do it on tests. All right, another one. What do you think? Can I point, vote with your thumbs. Can I point to what is my variable here? Y. Can I point to a single Y? No, you see the difference? This time I definitely cannot. How many Y's do you see up there? 3, yeah. There's not a single Y, there are multiple Y's. So I can't isolate yet. Because I can't point to a single Y, I'm not ready to use inverse operations. I've got to use regular PEMDAS like we've been doing until I get to a point where I have a single Y. So what would I do first, simplifying here? Distribute. Yeah, if I look down PEMDAS, I mean, we could just actually use PEMDAS. Inside the parentheses, is there anything I can do? No. Those are not like terms, right? So I can't simplify inside the parentheses. I move on. Again, inside the parentheses, they're not like terms. So there's nothing to do there. No exponents, so I move down to multiply and divide, and yeah, I could multiply. Distributing in this case is multiplying, isn't it? Right, so step number 1 would be I'm just going to distribute the -3, and I'm going to distribute the -2. And what's that give me? What do I get on the left side, everybody? Help me out here. If I distribute the -3, -3 times 6y is, there you go, -18y, -3 times -10, plus 30. I've got my minus y, don't forget that. -2 times y, there you go. -2y, and then last, plus 10. Okay, so good. So we multiplied, that's our first step. Now we move down, add and subtract. What does that mean in this case? Like terms, okay. So I could combine the -18y and the -y, and that's going to give me, what's -18y minus y? -19y, there you go. Okay, so -19y plus 30 equals -2y plus 10. Okay, good. We're not quite done though. We still have 2 y's. So what do I need to do next? Okay, yeah, I need to move the y's to one side or the other. And that sounds weird talking about moving stuff in an equation, but I think it's a great way to think about when you're solving equations, is to think about it visually. Think about pushing things around. I want to either push the y's to the left side of the equation so I can isolate them there, or move them to the right side so I can isolate them there, right? They're both going to work, but there is one way that's slightly better. Should I push the y's to the right or the left, do you think? To the right, I agree. Well, how come the right? Okay, good, because I'll end up with a positive number of y's. We always want the coefficient of y to be positive. It would work both ways, but this way, when I end up eventually isolating y and I divide, I'm not dividing by a negative number. Is it a big deal? I don't know, maybe not. But dividing by a negative number just slightly increases your chance of making a mistake, right? So we're going to push the y's over to the right by adding 19y to both sides. Now what's that do? If I add 19y to both sides, I'm going to cancel that one. So I get 30 equals, what's negative 2y plus 19y? 17y. Okay, now, finally, vote with your thumbs. Can I point to a single y? Yes, I can. Okay, so now what do I do then? Once I can point to a single y? Inverse operations, right? Now I'm going to isolate. So we just work our way up. First, add, subtract. Is there anything I must add or subtract to both sides? Subtract 10. There you go. I'm going to subtract 10 from both sides. So that's step one. Now I'm in isolate mode, so I should cross something out. I should cancel something every time. And I did. Look, I canceled the tens from the right side. That's going to get me closer to getting the y by itself. So now I've got on the right side 17y, 30 minus 10, we all know that's 20. Okay, we're getting there. We move up a step. What's next? Yeah, we move up to multiply, divide, and I'd need to divide both sides by 17. Which allows me to cancel again, right? I get to cancel something, and I get the answer y equals 20/17. And I can't reduce that, so that's my answer. But I want to check it, right? We want to check it, so let's go back to Desmos. See if you guys can remember how to do this. .2017. Okay, what do I do? Okay, I need to do f of x. Now, I could, in this case, y is my variable, right? And I could just change them to x's if I wanted to in the problem. You know, it doesn't matter what your variable is, but we'll just leave it y. So I'm going to do f of y. And what's that going to be equal to? Remember, my job here is I want to be able to plug the answer into the original equation and get the same number on the left as on the right. That's how I would know that it satisfied the equation and it was a true solution. So what's f of y going to equal? Okay, the what? But what part of the equation? F goes on the left or the right? The left, okay. So what part is it equal to then? Just all that stuff. Everything that's on the left side of the equal sign, whatever it is, that's f of y. And I'm just going to type it into Desmos exactly the way it started. So -3 times the quantity 6y minus 10 minus y. Everybody agree that's everything on the left side? Okay, what do I do? What's next? Say it again. Oh, good, the next thing. So now the g is equal to the stuff on the right side, right? So I'm going to set up, I'm going to define what's on the right side. So we're going to say g of y equals everything on the right side. Well, the right side is just -2 times the quantity y minus 5. Okay, we're all set. How did I find it? Well, okay, because it has to be, I mean, why is it g? Just arbitrarily, because we use f, when we use functions, we just use f and g a lot for our functions. But we need to have a different function for the left side than the right side, so I can plug something into the left side and see what I get. But the right side's different, so I need a different recipe or a different function to plug into, right? So now what am I plugging in? What number am I plugging in for y? 20/17. Okay, so on the left side, I'm just going to do f of, and then I'm going to replace whatever I started with, which is a y, with the number 20/17. And what's it give me? Well, it gives me that weird decimal. Okay, that's everything. That's the left side, what it gives me if I plug it in. How about the right side? I'm just going to do g of our input number, 20/17. And if it gives me the same answer, then it worked. Did it give me the same answer? Okay, it did. Good. Now, that decimal, is that an exact answer? Not that we need it right now. It's not that big a deal. We just need to know that we got the same thing on the left and the right, and the decimal told us that. But just so we know, remember, if I wanted to get an exact answer for what the left side is equal to, how could I do that? Because that decimal is just an approximation. Yeah, I could hit the fraction button, right? Remember that Desmos is pretty smart. It knows that if a number is a rational number, which means it can be written as a fraction, it'll always give me a fraction button so I can rewrite that number as a fraction, and then it's exact. So if I push the fraction button, look what it does. It tells me that that's, as a fraction, that's 130/17, and I got the same thing on both sides, and so it checks out. I'll put this in the notes. Okay, because we got the same thing on the left and the right side. Oops, that's not a very good check, is it? There we go. Okay, I want you guys to try one of these. So before we get into special cases, let me... Okay, try that one. Go. Real quick, everybody do this for me. I'm... Attention up here real quick. So I'm satisfied everybody is good with the PEMDAS, right? Everybody saw right away. You couldn't point to a single y, so you had to combine like terms. You had to simplify until you had a single y. Then you used reverse PEMDAS, and we got the answer 11/17. Okay, now what I want you to do. Go back to your desks, and everybody, we need Chromebooks. Get a Chromebook. Get your Chromebook. Get logged in. What's that? Still can't hear you. Good. Now I want you to, we all got the solution, 11/17, but pretend this is a test. So we want to know if it's right before we hit submit. So now you're going to go into the Desmos Scientific Calculator. Here's what I would strongly recommend you do. Go to Google. We're going to check our answer with Desmos. What's the first step, everybody? F of y. Our variable is y, so we're going to do f of y. Okay, this is where I need everybody's attention up here, please. So f of y equals what? -3 times the quantity 6y minus 7. Now I got to go get out of the parentheses, right? Minus y. Why did we pick that? How come f of y is equal to that? Because, say it again. It's on the left. F of y is the expression on the left side of the equation. What else do I need to do? There you go. G of y is going to equal everything on the right, which is what? There you go. -2 times the quantity y minus 5. Okay, last two steps. Good, so we're going to evaluate that at 11/17. Plug it in. Let's make it an exact fraction. So on the left side, when we plug in our solution, we get the number 148/17. What's next? G of, same thing. And we got it, right? Everybody see that? If you haven't done it yet, just go through that process so you can remember it. Doing the process will help you internalize it and remember it for when you need it. Okay. Put that on there for our notes. And I bet you that's gonna about do it for us. Tell you what, let's call her quits there for today. I'll put the assignment up. Be sure, so when you're done in here, make sure that you actually sign out. Don't just close up the Chromebook or shut it down. Make sure you actually sign out, and you can just leave the Chromebooks out. You guys get out in 4 minutes.